In this video, we're going to do a performance test comparison against simple collision versus complex collision. And so Unreal, you can have two types of collision. If you look over to the right, see collision complexity, you can say, hey, I want to use the simple or the complex collision as my simple collision. And so this is actually what simple collision looks like. And if you look under the collision right here, you have simple and complex. So if we turn off the simple, you can see the complex collision. And then if you turn back on the simple, you can see the simple collision. The simple collision can either be made in like Maya or any application, Blender, or you can actually make it right here in the Unreal Engine. Collision is a pain, it's tedious, and it's very time consuming, especially anything that's halfway detailed. So for instance, on the stairwell, you can see that it's going to take a long time. On this one, I just turned on the convex decompose and cranked everything up and hit apply, so it made the collision, as you can see, but if you look at it, it does a terrible job. So really what you have to do is you have to manually create the collision. And let's go ahead and delete this just so you can see what a pain it is. So we're going to remove collision, and then let's say you wanted to create this. One way you could do it is just take this one box and then create the collision on that. Another way would be create a box, so it's going to make a huge box like this, and then you would make the box smaller like this. Oh yeah, you could probably already see what a pain collision is. It's just very painful. So now you can go down here, and then you could go down here and then put this here. Oh, so make a little box like this. So, and you get the point where, I mean, we don't have to go through the whole thing, but and then you'd put this in here, and you try to kind of put it as best you can, and make your collision. And then you would, you'd copy that, like just like you copy anything. Hold down the Alt key and then shift it over, and then and you'd keep doing this over and over. And if you have a lot of assets or static meshes, this can take a long time, and it's not even that perfect, but this is basically how you do it. And so you can see there's two primitives, and then each time you make one, you'll make another primitive. So it just takes a long time, but this is supposed to actually be better using this. It's supposed to be less memory intensive, but it just takes a long time. The other option would be, like we were saying, use complex collision as simple. So see how it's on simple, but it's using the complex collision, which looks absolutely amazing. Look at that, perfect collision. But they say it comes at a hit. So if we open up Unreal's website, it says, so look here, it says use simple as complex. So if you're saying if you do use simple as complex, it says it helps save memory since we don't need to bake the tri-mesh and can improve performance if the collision geometry is simpler. So, and they say something here that you can sometimes use the complex as simple, but they really don't go into detail, how much it's going to cost you. So in this test, that's what we're going to do. We're going to see how we're going to do a real world example and see how much it costs. Is it very expensive? I mean, to use this on a couple items, is it going to be 20 megs worth of memory and 20 frame rates, or is it going to just be very minimal? So that's what we're trying to find out. One note to also take in consideration: if you use complex as collision, you can't simulate physics on it. So this would really just be for anything that's going to be static, that stays in one spot. It's not going to be anything that you're going to apply physics to, and it's going to be moving around. If you do that, you're forced. You have to use the simple collision, and you have to leave it over here on project default, and that way it'll use a simple collision. So you have to make your own collision. And again, I wish somebody would come up with a tool that took this complex collision and makes an exact duplicate, but makes it a simple collision, and then makes it where you can edit the simple collision if you wanted to tone it down. I think that would be a awesome tool for somebody to make. But anyway, let's get back to the test that we're going to do. So what we did, we created a map, and it was called complex, and we made 100 the staircases, which are pretty complex. They have a lot of different parts on them and a lot of collision. And then we made exact duplicate of the map, and then we deleted all the complex collision, and then we made 100 simple collisions. So it's a perfect. And then we baked the map, and then we after it was baked, then saved it or packaged it, and then packaged them both. So, because sometimes if you, in the Unreal Engine, if you're trying to do performance test, and you'll notice that sometimes this will be at 120, and then sometimes it'll go to 30. It's just not a good way to do performance tests. It's best to actually package the product, bake it, and then run the test on it. So the first test that we're going to do is actually just look at the frame rate, and then we're going to look at the memory, compare the memory stats between the two. So let's start with the complex, and we're going to open that up here. And what we'll do is turn on a stat. We're just going to look at frames per second, and then we'll come back and like I said, we'll compare the actual memory usage. So as you can see, if we look off, we're about at 240, and this is the complex one. So you can see as we run into it, the collision is working. So we're at 180, 200, 180, 170, 200, 200. So pretty solid, almost, it's going down to about 170. Let's see, with 170, it looks like it's the lowest it's going. So it's hovering about from 170 to 200. And there's 200, 170, 200, about 200. So it's a little. So I'd say about from 170 to 200. It looks like 170 was like the lowest it's hitting. So let's close this one out, and let's see what kind of frame rate this is going to be with the simple. Okay, and then we're going to do stat FPS again. Now we're at 220 something. Let's go down here. Now we're going to look up. So around about 220, 180, let's see, 170, 170, 180, 170, looks like around 200. Man, it's really hard to tell. I mean, it almost looks, about looks the same here. 200, 200, 170, 170. When it seems like when we move around, it hits about 170. And we kind of stop, it goes about to 180. So, I mean, if there's a hit on it, I mean, it would be I couldn't even really see it. It'd be so small that it's really not showing. This is 100 objects, 100 complex objects. So I would say frame rate wise, I don't really see any difference on it. It looks about the same as using the complex versus using the simple. So I would say that's about a tie. So let's go over now and look at our stats memory. And let's see if we can make this a little bigger. Okay, kind of hard to see. The one on the top in red, that's the complex, and the one on the bottom is the simple. So this is actually just a detailed memory that we ran on both of those. So the static mesh index memory is 0.13. And so the static index memory is 0.13 on both of them. And then if we look here, the total memory is 0.10 megabytes, and the static vertex memory is 0.08. So they're identical. So each one of those are identical. Interesting. Now, and again, the top one is the complex, and the bottom is the simple. And this is just we just ran the memory statistics when we were running both of those. So the complex mesh is 37 megabytes and 3702, 3702. I don't know what this is, pack cache high water. This one looks to actually be a little lower than the complex one's a little lower, which is interesting. The used streaming pool wanted 3.11 on simple, 1.52 on pixel shader memory. Pixel 1.52, ICU data field memory used 0.57, 0.57, 0.36. Okay, looks like there's a little difference here. Looks like we may have found it here. So here's the only difference is oh, interesting, the navigation memory, which is what it is, 0.12 megabytes. So that's for the complex, and then the navigation memory is 0.11. So 0.01 more on the complex. Man, that's just very little. So it doesn't look like it's going to take a huge, I mean, it's just very, very minimal. I'm really surprised. I thought this was going to be, I thought the frames per second were going to be a lot lower, which, as you could see, you really couldn't see any difference at all. And then also I thought the memory was going to be a lot higher used, but it looks like using because I've heard so many stories and read so many articles on this status, simple collision versus complex collision, that there's such a big difference, and people are saying this and that, and I was like, man, I just need to do a real world test and get to the bottom of this. So it looks like here's the bottom of it right here. Navigation memory, it uses just 0.1 more in this test with 100 complex objects. So very interesting, not much at all. So in saying that, I may, for some of my meshes, I may go ahead and use the complex. It just saves a ton of time until they come out with some tool that'll make it a lot easier. But anyway, I'd love to hear your comments. Love to hear your comments, because this is a huge collision is such a big part of any game that you make. It's a night and day difference. You don't have a collision, you're just walking through everything. So you have to have collision, and I would love to hear anybody's opinion on this. All right, thank you for watching, and have a great night.